The traditional WDM system uses tributary line integrated boards that receive multiple services on the client side. These services are then processed on the board and converted into ITU-T-compliant wavelengths for transmission. This technology has several disadvantages. First, the bandwidth isn't fully used, like loading a shipping container with too few goods to fill it up. Second, service grooming is not flexible enough. In traditional WDM networks, rerouting services to alternative paths requires on-site manual fiber connection, resulting in low operational efficiency. In 2002, the ITU-T released a series of OTN standards, including G.709, G.872, and G.798. The optical transport network typically comprises tributary boards, line boards, and ODUK cross-connection units. OTN has the following advantages. 1. Higher network bandwidth utilization. OTN introduces the concept of ODUK-level cross-connection, enabling service grooming with granular support for both fixed-rate services 1.25G, 2.5G, 10G, 40G, and 100G, and flexible rate services ranging from 1.25G to 100G. OTN provides a transparent transmission mechanism, allowing multiple low-rate service signals of any type to be multiplexed into the ODUK structure. This mechanism maximizes the network side bandwidth and eliminates resource waste. 2. More flexible service grooming. OTN supports electrical layer cross-connection grooming, enabling flexible service grooming through remote NMS configuration. This eliminates the need for on-site manual fiber connection, significantly improving operational efficiency. 3. Enhanced service protection capabilities. In addition to traditional 1+1 SNCP, 1+1 intraboard protection, and 1+1 linear protection, OTN can also support ODUK SNCP protection, which uses dual fed and selective receiving functions to achieve ODUK-level service protection. More comprehensive maintenance capabilities. OTN features rich overhead bytes that support comprehensive signal monitoring and alarm reporting. This enhances OAM efficiency and facilitates the evolution of WDM networks from traditional point-to-point architectures to more advanced topologies such as ring and mesh.